Look at your hand right now. Whatever shade it is, that color did not come from nowhere. It came from one of the longest survival stories in the history of life on Earth. And the wildest part, it was not random, not an accident, not a roll of the dice. It was a slow-motion biological negotiation between your ancestors and the sun. And the sun, for the record, was absolutely not playing fair. The answer involves vitamin D, cancer, folate, ice ages, and ancient farmers who accidentally rewired their own evolution. If you trace the human family tree all the way back, every single ancestor had dark skin. Every single one. Not most. Not the majority. All of them. 300,000 years ago, when Homo sapiens first appeared in Africa, the entire species was dark-skinned. There were no pale people. No fair-skinned populations. Anywhere on the planet. The concept of light skin did not even exist yet in humans. At some point, something happened. Something powerful enough to change entire populations. To understand what, we first need to understand what skin actually is. Most people treat skin like it is just the bag the body came in. But skin is your largest organ. And it is doing about 47 jobs simultaneously right now. One of the most important, protection from UV radiation. UV radiation is the invisible energy the sun fires at Earth constantly. And it is not your friend. UV light breaks chemical bonds. It damages DNA. It causes mutations in your cells. And if those mutations pile up in the wrong places, over enough time, they become cancer. Specifically melanoma, one of the most aggressive forms of skin cancer. Now, here is where skin color becomes relevant. The pigment that gives skin its color is called melanin. And melanin is, in the most literal biological sense, a sunscreen. The more melanin, the darker the skin appears. The more effectively it blocks UV. Dark skin is not just a look. It is a shield. This is why, in Africa, where our species originated, evolution selected hard for dark skin. More melanin meant better DNA protection. You lived longer. You reproduced more. Your genes spread. Natural selection is a very slow, very ruthless optimization algorithm. It runs one calculation over and over. Does this trait help you survive long enough to reproduce? In equatorial Africa, dark skin was an emphatic yes. Every generation. Every time. But here is where it gets unexpectedly complicated. UV radiation does not just attack your skin cells. It also attacks something inside your body. Something small, invisible, and critically important. Something that, if destroyed at the wrong moment, can end a pregnancy before it begins. The molecule is called folate, a form of vitamin B9. Folate is critical for the development of the neural tube in embryos. The neural tube becomes the brain and spinal cord. Without enough folate, the neural tube can fail to close properly. The consequences are catastrophic. Neural tube defects, severe developmental abnormalities, miscarriage. Here is the problem. UV radiation destroys folate. In a sun-drenched environment like equatorial Africa, UV exposure was constant, intense, unavoidable. Pregnant women with lighter skin had more UV penetrating deeper. More folate destroyed. More folate destroyed meant more neural tube defects. Fewer surviving offspring. So now we have not one, but two completely independent reasons why dark skin was essential in Africa. 1. Melanin protected DNA from UV damage. Reduced cancer risk. 2. Melanin protected folate in pregnant women. Preserved reproductive success. Two separate threats. One biological solution. Dark skin in Africa was essentially mandatory. So why did it change? Why did populations that left Africa get lighter and lighter? The answer is one of the most elegant, brutal trade-offs in all of evolutionary biology. Between 70,000 and 100,000 years ago, groups of Homo sapiens began leaving Africa. It was not a dramatic event. No meeting. No announcement. Just slow generational drift. A group moves a little further than their parents did. Their children move further still. Over thousands of years, humans spread through the Middle East, Europe, Asia, and the Americas. And as they moved north, something fundamental about their environment changed. The sun got weaker. Not the sun itself, but what reached them. At higher latitudes, sunlight hits Earth at a lower angle. UV is filtered by more atmosphere. Days are shorter. Winters are long and dark. The sky is overcast for months. In northern Europe, the UV environment is radically different from equatorial Africa. Instead of relentlessly intense radiation you need to block, you have weak radiation you desperately need to absorb. And suddenly, the dark skin that was perfect in Africa became a problem. Not because of cancer, not because of folate, because of something different. Vitamin D. Vitamin D is synthesized in the skin when UVB radiation hits a specific compound. Your skin is literally a solar panel. It uses sunlight as an energy source to manufacture vitamin D. And vitamin D is not optional. Not even a little bit. It regulates calcium and phosphorus absorption in the gut. Without it, calcium does not get properly absorbed, no matter how much dairy you consume. Without calcium, bones do not mineralize correctly. In children, severe vitamin D deficiency causes rickets, a disease that softens and deforms bones, bows the legs outward, stunts growth. In adult women, vitamin D deficiency can soften the pelvic bones. And softened pelvic bones make childbirth extraordinarily dangerous, sometimes impossible. Women with severe vitamin D deficiency had dramatically higher rates of death during labor. Vitamin D deficiency does not stop at the skeleton. It impairs immune function too. It affects muscle strength, cardiovascular health. Some research links it to depression. When vitamin D runs out, the body starts failing in multiple systems at the same time. Now, put a dark-skinned person in Northern Europe 40,000 years ago. They have highly efficient melanin. Their skin blocks UV beautifully, which was brilliant in Africa. But in the gray overcast north, that same melanin is blocking the UV they need. The skin cannot tell the difference between dangerous UV it should block and useful UV it desperately needs. So they do not make enough vitamin D, calcium drops, bones weaken, children develop rickets, women die in childbirth, the population starts declining. Dark skin in northern latitudes, in a world with no supplements or medicine, was a death sentence across generations. And evolution, that cold, merciless patient calculator, started selecting against it. Mutations that reduced melanin production began appearing in the population, randomly, as mutations always do. But instead of being eliminated, they spread. Because individuals with slightly lighter skin synthesized slightly more vitamin D, had slightly healthier bones, slightly higher reproductive success. Generation after generation, slightly lighter, slightly lighter, slightly lighter. Over thousands of years, the average skin tone of northern populations drifted toward lighter. Not because anyone decided it should, not because of culture or preference, because in that environment, lighter skin kept more people alive. The algorithm had reversed its inputs. For a long time, scientists assumed this happened gradually over hundreds of thousands of years. Recent ancient DNA analysis completely demolished that assumption. Early European hunter-gatherers, who lived in Europe for tens of thousands of years after leaving Africa, were still significantly dark-skinned. Even after living at northern latitudes for a very long time, they had not dramatically depigmented. The most famous example, a specimen known as Cheddar Man. He lived in what is now Britain approximately 10,000 years ago. Ancient DNA analysis published in 2018 revealed something surprising. He likely had dark to medium dark skin, dark curly hair, and blue eyes, a combination that looks almost paradoxical to modern eyes. Dark skin and blue eyes, because we have come to associate blue eyes with very pale skin. But 10,000 years ago, that was not yet the case. The extremely fair skin we associate with northwestern Europeans today appears to have spread widely only in the last 6,000 to 8,000 years. That is shockingly recent. In the full 300,000-year history of Homo sapiens, that is less than 3%. So what happened 6,000 to 8,000 years ago that suddenly accelerated this so dramatically? The answer is one of the biggest transitions in human history, and almost nobody talks about its effect on skin color. The Neolithic Revolution. The switch from hunting and gathering to farming. When humans transitioned to agriculture, their diet changed completely and permanently. Hunter-gatherers ate a varied diet that naturally included significant amounts of vitamin D. Fatty fish, organ meats like liver and kidney, shellfish, animal products, rich vitamin D sources all. Farming populations ate mostly cereals, wheat, barley, oats, rye, carbohydrates. Their dietary vitamin D intake did not just drop. It collapsed. Suddenly populations were almost entirely dependent on whatever their skin could produce. And if their skin was still fairly dark, that was not enough. The selection pressure for lighter skin intensified dramatically. Even tiny increases in vitamin D synthesis ability became critically important for survival. But there is a second factor that made this change happen even faster. Farming communities were large, dense, sedentary, and population density affects how fast mutations spread. In a small hunter-gatherer band of 50 people, a mutation takes a long time to spread even to neighbors. In a farming village of hundreds connected to other villages, a mutation can spread through thousands in just a few generations. The combination, dietary vitamin D collapse plus population density, hit the fast-forward button on depigmentation. Within a few thousand years, what had been quietly nudging for millennia became rapid and visible. Now, here is something that genuinely surprises most people. Skin color is not controlled by a single gene. There is no dark skin gene and light skin gene. It is controlled by dozens of genes working together. Genes that influence how much melanin is produced, what type of melanin is made, how it is distributed. And here is what makes this truly remarkable. Different populations that evolved lighter skin used different genes. East Asians and Europeans both have significantly lighter skin than equatorial Africans. But the genetic variants responsible for lighter skin in East Asians are largely different from those in Europeans. They arrived at similar outcomes through completely different genetic routes. This is called convergent evolution, the same adaptive solution discovered independently through different genetic pathways by separate populations on separate continents. When evolution keeps reinventing something from scratch, that is a strong signal the trait really matters. Now, let us talk about blue eyes, because the story is equally mind-bending. Every single person alive today with blue eyes is descended from one specific individual. One person, one mutation, one moment, somewhere around the Black Sea region, approximately 6,000 to 10,000 years ago. Before that individual was born, the entire human species had brown eyes. Everyone, brown. Then this one mutation appeared, a change that reduced melanin production specifically in the iris. And it spread, slowly at first, then faster, because it was probably genetically linked to skin pigmentation variants that were themselves under strong selection. Now consider this. Blue eyes, something used throughout history to sort and categorize humans, is younger than the invention of agriculture, younger than Stonehenge, younger than the domestication of the horse. We treat certain human traits as ancient and fixed, when they are in geological terms brand new. The version of humanity we think of as normal and fixed is still being written. Now, let us take a step back and look at the full picture. Skin color, the thing that has defined so much of human history, shaped political systems, justified atrocities, divided people into hierarchies for millennia, is at its biological core a UV calibration system. It is a dial, an adjustment mechanism, your body's best ancestral estimate of how much sunlight protection you need, based on the latitude your ancestors inhabited, the diet they ate, the sun they lived under. Light skin is not better in any absolute sense. In equatorial environments, it is actively dangerous. More UV penetration, more DNA damage, more cancer risk, more folate destruction. Light skin in Africa is a survival disadvantage. Dark skin is not less evolved or primitive. It is the ancestral state, the original configuration, the baseline. Lighter skin is the newer version, the adaptation, the variation. Dark skin is the default. And the deepest irony of all, the same sun that drove some populations to develop more melanin to survive its power, also drove other populations to develop less melanin because they needed more of its limited energy. The sun did not pick sides. The sun just radiated indifferently and let evolution sort out the rest. We built an entire civilization's worth of prejudice and hierarchy around a vitamin D problem, a calcium absorption issue, a folate protection mechanism. That is all this ever was. Human populations are still evolving, slowly, almost imperceptibly. But we have vitamin D supplements now, sunscreen, fortified foods, electric lighting. We have built a civilization that partially decouples skin biology from its original function. The evolutionary algorithm is still running, but we have changed the inputs. Every shade of human skin that exists today is the product of the same ancient population, standing in the African sun, slowly spreading across an unpredictable planet, carrying written in melanin the precise record of every environment their descendants passed through. Every skin tone is an answer to a question asked by a star. If this made you see your own skin differently, that is exactly what this channel is here for.